Hello students, you all are warmly welcome. We are going to present you another lesson that belongs to Unit 2 in your chemistry, grade 12. Students, here in this lesson, we are going to focus, we are going to look at the way how to draw those Lewis structures. We are going to find it out, the method how you could successfully draw a Lewis structure there. What is a Lewis structure? We'll first look that out, what is a Lewis structure. So then let's learn the way how to draw Lewis structures. So students, finally our target is leaving here from this lesson as with giving you the talent of drawing Lewis structures. Then students, we are going to start with that purpose, we are going to start our today's lesson. Students, Lewis structures. What you here see is a Lewis structure. Drawn for what? It's carbon dioxide. So you wait. You also would be able finally to draw such structures standing for various substances, various molecules, not only molecules, but also for various ions you get there. Okay, be with us. Students, you could find this under the competency unit 2. It says what? Relates bonding and structure to properties of matter. There under that we are going to look at the competency level. It's 2.1 and 2.2. 2.1 says analyzes the primary interactions of polyatomic systems by means of determining the structure and properties of matter. Then under 2.2, what does it say? It says analyzes the shapes of covalent and polar covalent molecules and simple ionic groups. Okay, then let's find it out. What do we have as the subject content under this? Okay, students, it's subject content. Under that you could find that out, structure of molecules and ions. It's Lewis structures. Then there are various such structures as Lewis structures. It's dot crosses, dot cross, so dot dot and dot dash. Such various structures are there standing. Students, we are going to learn the rules for drawing Lewis structures. We are going to learn those rules there. Okay, students, then when you talk about these Lewis dot diagrams, we are going to we have various few different terms like Lewis dot diagrams and Lewis dot dash structures. Finally, our concern is to draw Lewis dot dash diagrams. But let's first look at all the various different types. You have Lewis dot diagrams, dot crosses diagrams, and dot dash diagrams. So students, in order to understand the arrangement of bond pairs and lone pairs in molecules and ions, a model was introduced by Gilbert Lewis. So it was in 1916. That's the basis. Then you could find it out, means Lewis structures to denote, to communicate with others, with the purpose of communicating with others, giving the idea of what kind of substance is this, what are the atoms and how many bonding you get there, and which atom has bound with which atom. Those things we are going to find here out. Then shall we look at the things it reveals by Lewis structures? Students, a Lewis structure, it illustrates these things. The atomic skeleton. What's the atomic skeleton? Skeleton is the frame. So atomic skeleton is, or skeleton of the ion is, the frame that you get, that you have standing for that particular molecule or that particular ion. That's what we call atomic skeleton, standing for that molecule or ion. So you would be provided with molecules for sometimes ions. When those are carrying charges, we call them ions. Okay. then students, it's very, very important us to know which atom has bound to which atom. So what is the charge they finally are carrying? So the frame is very important. It's what says the atomic skeleton. Then nature of the bonding present, single or double or triple. So it's, you could find between some atoms there are single bonds, some other atoms double or triple bonds. Being possible, they are within the molecule that you get there. Okay, then further it reveals the distribution of the valence shell electrons around each atom of the given chemical formula. Those stuff we could reveal regarding a Lewis structure, but it's, you can't find them out straightly by seeing that the Lewis structure, it's not available. The information is what the oxidation number, what's the hybridization standing for that each atom. So it's, we need to work out as to find them out later. So it's, those are secondary things. You can't straightly reveal those informations. These you could. Okay, okay. Then students, this is a Lewis dot diagram. This is a Lewis dot diagram. So it says that when you consider Cl2, when you consider CCl4, it says that you have two shared electrons between two chlorine atoms. And each chlorine atom is carrying 1, 2, 3, 4, 5, 6, including these two electrons in the bonding, it's 8. This number 8 is very, very important, a critical number. What's this 8? Students, mostly it's, if it's a last shell, it's, you would find S and P, those subshells being filled with electrons. S could carry maximally 2, P could carry maximally 6 electrons there. Okay, 6 plus 2 is what? It's 8 electrons there. We consider it as the stable electron configuration. It's the octet rule. Having of 8 makes them stable. Okay, so then it's, you find here around each chlorine atom, those two chlorine atoms have got 8 electrons. If I circle them, these 8 electrons now belong to the chlorine I have circled with. So these 8 electrons is common, means is, it belongs to that chlorine there. Then what about these 2 electrons? Those are 2 common electrons, shared electrons. We call it a covalent bond. Hope you could remember, we talked about what covalent bondings are. In our earlier lesson, we found that out. Hope you could still remember. Okay. Then students, it's, when we go to carbon tetrachloride, it's CCl4. Look at that. It's, you could find that out. The center atom carbon is carrying 8 electrons. It's then around this chlorine, this chlorine, this chlorine, this chlorine. Some other, these are the terminal atoms. We call them terminal atoms. So those terminal atoms also are carrying 8 electrons. Then these pairs, pair of electrons, stay alone. We call them lone pairs. Then this pair is shared between those 2 atoms, carbon and chlorine. So the shared electron is, it belongs to the bonding, so it's the bond pair. You have such pairs. Around an atom, it's possible you to find that out, lone pairs as well as bond pairs. Additionally, it's possible you to find out some non-bond, it's still not become a pair, it's at the state of non-bonding, so it's just a single electron. We call them unpaired electrons. In specially radicals you could find them out, single atoms you could find them out. So those are unpaired electrons, quite reactive than just these kind of molecules with pairs. Okay, so then students, let's go ahead. So when you denote those pairs of electrons, as I have already mentioned, you could find that out, single bonding carrying 2 electrons, 2 electrons. Those 2 could be denoted in the form like either in a line that link 2 atoms or in this manner perpendicular to that. So students, you could find some atoms carrying double bonds, means having 2 bonds there. When you have 1 bonding, it's 2 electrons you get there. If it's 2 bonding, 2 into 2 electrons you get there. What's 2 into 2? It's 4, right? Those 4 electrons, you could find them out in this manner, a double bond, or otherwise in this form, it's a triple bond you get. Okay, then some other bonding also are possible. I would call them dative bonding, but it's another way that you represent a covalent bonding. When one atom is given both electron and other atom just come in with empty atomic orbital, we call them a dative bonding. So when you have a dative bonding, then also you could just represent them with 2 dots in this way. Okay. Then students, it's Lewis dots crosses diagram. What about those? Here it indicates those bonding, not only bonding, it's when you represent the electrons of one atom with dots, the neighboring atom, its electrons you could show with crosses. That's what we draw there as saying it's the Lewis dot crosses diagram. Students, let's find more information out regarding Lewis dot crosses diagram. It's the same 2 molecules I have given. What those? RCl2 and CCl4. Then these are the electrons came with that chlorine. But after sharing, now these all, including this cross, belongs to the valence shell. We call it the valence shell of chlorine, the outermost shell. So is now carrying 8 electrons. Then this is a cross. That cross denotes it does not belong to this chlorine, but the other chlorine atom. So all the electrons come with this chlorine are denoted with dots. The other electrons come with the other chlorine are denoted, neighboring one, with crosses. Then it's the dot crosses diagram, dots crosses diagram. So then similarly here dots are the electrons from one chlorine atom, then the neighboring atom is a carbon, so its electrons are crosses. These are the crosses. Then neighboring to carbon you find other 3 chlorine atoms are denoted with what? It's with dots. Okay, those what you get as dots crosses diagrams. Then it's finally what we have got is this, is what we are going to talk about in our further informations regarding our lesson. We are going to draw their structures. They are Lewis structures. When it calls a Lewis structure, students, it basically stands for Lewis dot dash diagrams. Then let's find it out how to draw Lewis dot dash diagram. So students, a bonding would be denoted with a dash, means a short line, while other electrons belong to the atom denoted with dots. You could denote 2 dots close by a lone pair, a single dot unpaired electron. So those are the stuff regarding Lewis dot dash diagrams you need to know. Then there are few rules that you need to know regarding drawing of Lewis dot dash diagrams. Okay, let's find them out. What are the set of rules to be followed there? Okay, then this is a Lewis dot dash diagram. So students, this is the bonding. So it has denoted with a dash, a short line. Then these 4 are bonding, and all the other dots are standing for lone pairs. Electrons that do not belong to bonding are lone pairs. So is the way we represent them. Okay, hope is clear. Students, let's go ahead. So it's we are now going to, here on, we are going to find it out how to draw these what? These Lewis dots dash diagrams. Okay. Students, you need to first find it out. The number of electrons that you have. Number of electrons that you have with each atom that you would be provided with, it's the example H2O, you would be provided with a molecule here, or otherwise it's H3O plus, it's an ion. Though it's a molecule or ion, it doesn't matter. First you need to take the count of total electrons. In that aspect, you need to know how many electrons are coming with that particular atom. It's not the total number of electrons that atom belongs. I mean, if it's sulfur, students, sulfur is having 16 electrons. But here when you take a count of electrons that all the atoms' valence shells are carrying, we do not take 16 for sulfur. We take 6 only. Then it's very, very important you to know how to get this number of electrons with the valence shell of each atom. It's very simple. You look at the group number of the atom. Group number means in the periodic table that particular element you could find that in the first group, second group, third group, in that manner in a group. If it's a first group element, students, it's obviously you would get 1 electron there. 1 electron there if it's a first group element. What about second group? Then it's 2 electrons. Then it's in your O level you learned it as third group, but now it's the 13th group. If it's a 13th group element, students, it's having 3 electrons. Boron, aluminium, gallium, indium, thallium. Those are 13th group elements. They are carrying 3 electrons in their valence shells. What about 14th group? Carbon, silicon, germanium, tin, lead. They are carrying 4 electrons. 14th, 4 electrons. 15th, 5 electrons. 16th, what? 6 electrons. 17th, hope you guess. So 18th, it's 8 electrons. 17th, 7 electrons. Okay, then in that manner, it's anyway, hydrogen is carrying only 1 electron. So then hydrogen is giving 1 electron there. So you have such 2 hydrogens there. 1 into 2 is what? It's the most difficult question. 1 into 2 is 2. Then students, when you talk about oxygen, though it's having 8 electrons, this is not about all the 8 electrons. This is about the outermost shell, valence shell electrons. It's 6 only. It's 6 only you are having. So the count is 8. You take the total number of electrons given. If it's a molecule, it's that way. But what about it if it's an ion? It could be a positively charged ion as well as negatively charged ion. Students, if it's a cation or anion, then also we could accordingly find it out the number of electrons there. Total number of electrons in their valence shells. Finding out of that is our first target. Okay, so if it's an anion, then you first take the count as atoms are given. Hydrogen atom is given 1 electron. Then it's oxygen you have given how many electrons there? Hope you could remember, it's 6 electrons. Then students, what does it mean by it's negatively charged, by an anion? Anion, negatively charged ion, says that it has taken 1 electron if it's -1, 2 electrons if it's -2, 3 electrons if it's -3, the charge. Then accordingly, if it has taken that number of electrons, then you add such electrons there. I mean, if it's a negatively charged, you then give 1 electron. Negative charge means it has taken 1 electron. Then it is another electron you need to add. So then you take the count, it's again 8. Then let's find it out, it's through an example how you could manage it when it is a positive charge. Students, it's very easy. So when it's a positive charge, you deduct 1 electron. So its nitrogen is given how many electrons? It belongs to 15th group. Nitrogen is given 5 electrons. In its valence shell, you could find 5 electrons. Hydrogen, each hydrogen is given 1 electron into, you have 4 hydrogens there. Into 4. 1 into 4 is what? It's very, very difficult. So answer that, it's 4. It's 4. Then students, it's plus 1 is the charge. Plus 1 is the charge. If it is plus 1, the charge, then it means that it has lost 1 electron. It has removed 1 electron. That's how an atom or group could become positively charged. It lacks 1 electron. So it's then you need to deduct 1 electron there. So then what's the total? It's again 8. 8 is the total. In that manner, it's you need to take account of the total number of electrons there within that molecule or given ion. It's very easy. That's the very first step you need to follow. Then students, you need to find it out. The number of total electrons here, pairs. Total electron pairs you need to find there out, standing for that particular molecule or ion. Okay, how could you reach that? It's simple. You need to know multiples of 2. You divide that by 2. The total number of electrons, you divide that by 2 as to get the total number of electron pairs. If it is non-dividable, if it is not an even number, you can't divide it by 2. Unless you have an even number. If it's an odd number, students, you could divide the maximum number of as it reaches the maximum number of pairs, you could divide 1 before the value being given. Means if it is 9, you deduct 1, it's 8 then. Then you have 4 pairs and that deducted one is 1 electron. So then students, that's how we get the number of electron pairs. Then we need to decide the skeleton of the molecule or ion. What's the skeleton? It's the frame. It's the frame of the molecule or ion. Then it's very, very important finding out how those atoms were being bound. Means it's you could if it is few atoms being given, you could just imagine it's in this combination those atoms could get combined, means adjoin. Or another combination also you could imagine. So the most logical combination is the true structure. In that aspect, students, we need to know the skeleton, the exact skeleton. So mostly you would be provided with structures, molecules or ions, with 1 atom at the mid. 1 atom at the mid. The mid atom is referred as the central atom. It's 1 central atom at most of the time with our level, the provided structure could carry there. So at most of the time, therefore, the skeleton would carry 1 central atom. Then it's very important which one is the central atom and which atoms are not the central atom. Except the central atom, others atoms are the terminal or peripheral atoms. Okay, it's that simple. But the identification of the fact that which is the central atom is very, very important. It's critical. It's going to be critical. Students, the atom forming many bonding would be the central atom. Then in that aspect, I could help you saying this. It's some atoms, they do not form more than 1 bonding. It's you have hydrogen and fluorine. They form 1 bonding only. Therefore, they never would play the role of central atoms. Central atoms. Then it's except then except them, the atoms, when you have some other atoms also, the atom with least electronegativity possible to be the central atom is how we decide the central atom there. The atom with least, when you compare their electronegativities, you need to have just a comparative idea. You shouldn't by heart those values there, standing for the electronegativity of all the elements. No, you shouldn't by heart them. But students, you need to have simply a comparative idea. How is that the electronegativity of these compared to this? It's less. Compared to this, it's more. In that manner, you need to have an idea, at least a rough idea. That's enough. That's enough here. The least electronegative atom is the central atom going to be. Then students, in that aspect, when you check, right, when you check for the central atom, let's find it out. Let's work out some examples, finding out what's the possible central atom standing for these molecules or these ions. Then other atoms, regarding other atoms, we call them terminal atoms or peripheral atoms. Other atoms, not heteroatoms, right? Other atoms, students, at least you need to have between central atom and other atom one bonding. So they need to have a linkage. If they are not linked, then it's not a structure. So it's one structure we are drawing, so therefore at least one bonding you need to state there as the link made between central atom and other atoms. At least one bonding you need to state there on each atom. So drawing the skeleton or skeletal structure, let's first draw one single bonding, one short line, dash. We'll draw one dash there between two atoms, linking them, saying it's the skeleton. Then let's place all the other electrons you get there as it completes octets. Octets means 8 electrons. As it completes 8 electrons, making them stable, let's place those all electrons on other atoms. Then let's find our chances to write either double or triple bonds, if it's possible. Okay, is the way we are going to handle it. Then students, let's draw skeletal structures standing for these two. Okay, so far we have found that out H2O is having 8 electrons there. So it was in this manner. Hydrogen is giving 1 into 2 is 2 electrons. Its oxygen is giving 6 electrons. Its summation is 8. Then students, 8 divided by 2 is the total number of pairs. It's total number of pairs, not apples, right? So it's 4 you get there. Then students, imagine the central atom. So though it's not the least electronegativity carrying by oxygen, hydrogen is forming one bonding only. Therefore students, there is no chance for hydrogen to be the central atom, it's the oxygen. This is the skeleton. So if we talk about NH4+, we have already found that fact out there. The total number of electrons 8. Let me show you that. Nitrogen is giving 5 electrons. Each hydrogen 1 into 4 is 4 electrons. Plus 1 charge is giving minus 1. The number of electrons, it's 8. The total. You divide 8 by 2. It's 4. The number of total pairs. Then students, we can't take hydrogen to the mid position. So let's take nitrogen to the mid position. So let's draw at least one bond in there. So it was 4 bonding drawn. Then each bonding takes a pair of electrons there. Then students, you have 4 pairs being used up. So you deduct 4 from that 4 total number of pairs. So it's you get 0. You have no electron pairs left as to place further. But regarding this water structure, it's you have 4 pairs, total pairs. It's students, you deduct, it's 1, 2 bonding there. You deduct 2 by 4, it's 2. You have another 2 pairs kept on some atoms. So the only possible atoms you could keep those 2 electrons here. I'm going to explain that further in our future points. Okay, then it's the marking of lone pairs. That's what I have mentioned earlier. So students, after reserving some pairs from the total number of electron pairs for bonding, saying them are the bond pairs, those are the bond pairs. What about remaining bonding, remaining electrons? Remaining electron pairs, we deduct the bond pairs or number of bonding from the total number of pairs and the electrons left over, so are going to be named as the lone pairs if you have sum of pairs. Otherwise, if it's just 1 electron, it's very rare the situation or a chance you could have just 1 electron, then we call it unpaired electron, single electron. Anyway, if you have further pairs remaining out of total pairs, you simply deduct the number of bonding reserved for the skeleton, then those are the lone pairs. That number of pairs is the lone pair number. Okay. Then it matters on which atoms we could reserve or we could place those lone pairs. In that, students, you check for the most electronegative atom. We don't have a chance for hydrogen. Hydrogen has 1 shell, first shell only, so it could maximally carry 2 electrons. If there is a bonding, that's done. Therefore, you ignore hydrogen here. Then you check other atoms. Out of those atoms, it's the atom with greatest electronegativity deserves for the next keeping of those pairs as lone pairs. You first keep those lone pairs of electrons that you have got remaining on such atoms. The most electronegative atom first, then in the decreasing order of their electronegativity, if you have further remaining. How could you decide how many pairs to be kept on that most electronegative atom? Students, it's maximally 8, means 8 is the stable number. We found out earlier. So you make the number of electrons in its valence shell of that most electronegative atom 8, you make it 8. Then if you have further remaining, you go to the next secondly most electronegative atom. So next one. In the descending order of their electronegativities, you place those lone pairs left behind there on those atoms. Okay, that's what our next target is. Then students, it's the same what I have mentioned. It's possible, you found that out at the very beginning, deciding your skeletal structure. The least electronegative atom was the mid atom. Then most electronegative atom or atoms would be terminal atoms. You place those electrons, lone pairs on terminal atoms after drawing the skeletal structure, remaining pairs, as it then gives octets, 8 electrons there on each atom. If you have further electrons left, then you go to the other atoms in the descending order, decreasing order of their electronegativity. So here, when I start drawing this, students, its carbon is given 4 electrons, each chlorine is given, it's a 17th group element, it's given 7 electrons into, you have such 4 chlorine atoms there. So it's 28, so the summation is 32. You divide that by 2. So you have 16 pairs of electrons. Then students, it's out of chlorine and carbon. Carbon is the least electronegative. So let's place carbon to the mid position. So let's then place those chlorine atoms, 4 chlorine atoms to the terminal positions. They are the lateral atoms, peripheral atoms. Then students, we have drawn in the skeleton, we have drawn already 1, 2, 3, 4 bonding. It's 4 bonding we have already drawn there. You deduct 4 by 16. So you get 12. You have another 12 pairs of electrons left behind. Then out of carbon and chlorine, the most electronegative is chlorine. Hope you know that. So students, you complete octets around its. You consider a bond is carrying 2 electrons. Then it's the shared 2 electrons. Then this chlorine and this carbon both are sharing those 2 electrons. Then it's common, these 2 electrons to both chlorine and carbons, they are valence shells. Therefore, 2 electrons coming with the bonding is owned by not only chlorine but also carbon. So it's 2 from the bonding and another 2 by the lone pair, another lone pair, it's 6, another lone pair, then it's 8, then it's 8. Then it's 3 pairs it took to complete the octet. Then another 3 such we have. Let's place on each chlorine, let's place 3 pairs, 3 lone pairs on each chlorine. It's easy. Okay. Then students, this took all 12 electrons, 12 pairs. Then it's 12 minus 12 is 0. You have no further pairs of electrons left behind. That's it. That's how we place those pairs of electrons remaining there. Hope you could understand. Okay. Is the next point, next one. So let's go ahead. Then it's further. Then in earlier example, it was central atom was the least electronegative and others were the most electronegative atom. So we could not help it. So then sometimes it's possible the most electronegative atom, that role played by central atom. It's very rare, but it's possible. When you have hydrogen there, being terminal atoms. So it's ammonia. Then students, though it's the terminal or mid atom, it doesn't matter. You decide where to place the lone pairs first. It has to be the most electronegative atom. You need to start it with the most electronegative atom. As we started the vaccination, right? Most vulnerable people, we started with them, the vaccination process. Hope you could remember. It's the same, right? So, its students, we have nitrogen giving 5 electrons, hydrogen giving 3 electrons, it's 8, it's divided by 2 is 4, is the number of pairs you have. So, it's the skeleton you need to draw having 3 bonding there with 3 nitrogens there. So, students, it's 1, 2, 3 pairs already taken. So, another 1 pair it remains. Then you place that pair on the most electronegative atom is the nitrogen. Okay, you place your pair remaining there on nitrogen. Okay. Then students, we have discussed these things. When you have pairs remaining, you place those pairs, you make sure you are placing those pairs as completing octets on those atoms. First you go for the most electronegative atom. Then in the decreasing order, descending order of their electronegativity, you fill in those electron pairs. Okay, that's what we need to do. You need to first take account of total electrons, then total pairs. Then you need to draw the skeleton. Then you need to keep those pairs on those atoms in the order of their electronegativities as you complete the octets there. Okay, then students, some atoms, they are coming with a certain number of electrons there in their valence shells. Like as we have already found out, if it's nitrogen, it's 5 electrons you could find in its valence shell. If it's sulfur, it's 6 electrons. If it's chlorine, fluorine, it's 7 electrons you could find there out. Okay, then its students, you now would be having the idea, anyway it came with this number of electrons. Now it's having this number of electrons. So it's not fair. Oh, it's different. Oh, it's the same. If it's the same, then it has not taken or removed electrons. Then the charge is 0 with them. No additional, no extra electrons on those atoms you have extra placed or removed. Then students, but it's if you find a greater number of electrons than earlier, means than the electrons it has come with, then it is having more electrons. It's a negative charge you need to place. We call this the formal charge. Then next is the placing of formal charge. Before giving the formal charge, let me explain this as well. Students, it's phosphorus is given 5, chlorine is given 7 into 3, it's 21, it's 26. The number of pairs there, number of electrons there, number of pairs there is 13. So you make phosphorus the less electronegative atom to the mid position. Then it's 3 it took, so it is 10 remaining. You complete those octets here, place in 3 pairs. Then it took 9 for that. Then it remains 1 electron pair. Then you place it on phosphorus. That's the way. Let's go for the formal charge. Then students, we could assign the formal charge based on the electron amount it has got, and the electron amount now you could see there after placing those electron pairs. Okay, so then if it's a bond, when we count for the number of electrons it's now having, you make it as 1. So a bond is a sharing of electron. Therefore, if it's sharing electrons, then it's 1 electron given by that atom. But if it's a lone pair, you take the count as 2. That's what. So let me show you that. Its nitrogen is giving 5 electrons, hydrogen is giving 1 electron into 2 is 2 electrons, it's -1. The charge is giving 1 electron, so the total is 8 electron, number of pairs is 4. Then students, you shouldn't take hydrogen to the mid position, it's the nitrogen atom. This is the skeleton. You deduct 2 for the bonding there, 2 bonding. So it's another 2 pairs you have. You draw those on the most electronegative atom is the nitrogen. So you take a count now. That's what the formal charge. So that's how you could give the formal charge. Students, it's a bond. One bonding is having 1 electron of nitrogen. It's another bonding, 2 electrons. Another 2 pairs. Each pair is having 2 electrons. So it's 4 plus 2 is 6 electrons. But nitrogen came with 5 electrons. It's 1 extra charge you have. You place that 1 extra charge as -1. -1 is the charge, is what we call the formal charge. Formal charge belongs to that atom. Okay, it's very easy. Then students, it's when you have, right? So when you have such additional number of electrons, you place the formal charge as negative. And when you have electrons being lacking, then you place the formal charge as positive. Then our next effort, placing those formal charge, our next effort is drawing off bonding, minimizing formal charges. How could we manage that? Students, hope you could remember a dative bond. A dative bond could be drawn in the manner like this way. It's a pair. From the pair you draw an arrow. let's say A was carrying the pair, B came with empty atomic orbital. So this is how we could denote a dative bond. Same thing could be denoted by this way, drawing a single line, a dash. So it's the donor is assigned with the positive charge, positive, then acceptor with a negative. So in that manner, we could play with the charges they are having. We call that rearranging of those electrons. Those charges, let's say electrons and therefore the charges. Okay, it's our next effort is minimizing of the formal charge. In that we could take the support of this, what? Dative bonds. Students, if we are going to draw some dative bonds as to minimize the formal charge, then these dative bonds are drawing additionally, means already you have the bond in the skeleton. It's one bonding. So if you are drawing another bond, it becomes a double bond. Another two bonds, it becomes a triple bond. We can't help it. Anyway, it finally gives us the exact Lewis structure. That's what we are going to find here out. In this matter, on this matter, it's regarding these dative bonding. So it's if one atom is carrying a lone pair, only it could give those pair as to form a dative bond. The other atom needs to have an empty atomic orbital. Then students, in that aspect, it's all those elements you find in the second period of the periodic table. What are they? It's lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Then it's they have 2s and 2p only. Therefore, maximally they have 4 atomic orbitals only. 1 atomic orbital from 2s, 3 atomic orbitals from 2p. Then you can't give further bonding on them. They do not have any empty atomic orbital to receive those dative bonds. You make that sure you do not give more than 4, means you shouldn't use more than 4 atomic orbitals around those atoms. Okay, but if it is a third period element like nitrogen or phosphorus, it doesn't matter. More than 4 atomic orbitals they could use. For the reason it's additionally means it's after 3s, 3p, you have 3d atomic orbital subshell also being available to receive dative bonds. Okay, let's find that out, how to draw the Lewis structure of this. First, let's find it out the number of electrons, then we'll find it out the skeleton, then we'll assign the formal charge there, then let's minimize the formal charge rearranging electrons, drawing dative bonding. Okay, take a look at this. Its sulfur is coming with 6 electrons in its valence shell. Its oxygen is having 6 electrons into 3 such oxygens you have. It's 18 electrons. It's 24, the number of electrons total. So you divide that by 2. It's 12, the number of pairs you get there. Then students, then when you compare oxygen and sulfur, sulfur is the least electronegative. So it's you place sulfur to mid position, then this is the skeleton. This is the skeleton. Skeleton is used in 3 pairs. So you deduct 3, then it's 9. You then find out the most electronegative atom, it's oxygen. So you place 3 pairs on each oxygen as you complete the octets. Then it's 9 pairs being used, it's 0. You do not have further pairs to be placed there. Then assigning the formal charge. This bond takes 1 electron. I told you it's 1, 2, 3, 4, 5, 6 plus 1 is 7, but oxygen had 6 electrons only. It's 1 extra electron, now it is having -1 the charge on oxygen. So -1, the charges on oxygen. Then this sulfur was carrying 6 electrons, now 1, 2, 3 electrons only. So it's lacking 3 electrons. It's +3 the charge on sulfur, sulfur. Then students, you give dative bonds. You use this pair, you cut that pair here, use it in a dative bond. If it's a dative bond, donor needs to have a +1 and acceptor needs to have a -1. This +1 cancels with the -1. That's obvious. Then this -1 makes it +2 only having there. You do the same. From here, it's you cut the lone pair, drawing a dative bond. Then it's you assign +1 on donor and -1 on the acceptor. Then it cancels this charge. You have another opportunity. You use this pair as to form a dative bond. Then assign +1 on the donor and -1 on the acceptor. Then you get all being neutral. Then it's no matter, though it's greater than 8, the number of electrons, or though it's 1, 2, 3, 4, 5, 6, it's 6 atomic orbitals are using by sulfur. Sulfur is a third period element, it doesn't matter. It doesn't matter. So, if it's a second period only, you need to worry about the number of atomic orbitals. It's maximally 4 available, carbon, nitrogen, there. So, its sulfur is okay with 6 atomic orbitals. It's having more. It's maximally have 9 atomic orbitals, isn't it? Okay. So, I could draw it in this manner. Finally, now 2 lone pairs on each oxygen. It's carrying, this is the Lewis structure, minimizing the formal charge. There you get. It's very easy drawing Lewis structures. Then students, that's what I have told you, that regarding third period and second period, it's for the number of atomic orbitals you could use if the second period atom becomes the mid atom. If it's the third period atom, it's okay, maximally 9 orbitals you could use. Okay, let me show you how to draw SO3 2- sulfide. Its sulfur is giving 6 electrons, oxygen is giving 6 into 3, it's 18 electrons. This -2, the charge, is giving what? Is giving another 2 electrons, it's 26 electrons. You divide 26 by what? 2. Then you get 13 pairs there. Then it's sulfur, the mid atom. So it's sulfur, you take that to the mid atom, you draw the skeleton, is taking 3. For the skeleton, it's 10 the number of electron pairs. So you give octets. You give octets on most electronegative atoms first. It's 9 being used, another 1 remaining. The remaining 1 you keep on sulfur. Then students, you could give, you then check for the formal charge. It's having 1, 2, 3, 4, 5, 6, 7. It's 7, therefore -1 is the formal charge on oxygen. It's -1. Then what about sulfur? Sulfur is 1, 2, 3, 4, 5, carrying 5 electrons. It's lacking 1 electron, so +1 is the formal charge. Then you give dative bonding. So it's you give 1 dative bonding and see. Then it's +1 on donor, -1 on acceptor. The mid atom's charge is cancelled, and this atom's charge, oxygen atom, it also is cancelled. Then it's 2 of minuses left on 2 oxygens there. But if we try for further dative bonding, those would be cancelled, but the minus charge would be appeared on sulfur atom. Therefore, we can't let that happen. So students, therefore, this is the best. So we settle with that. It's the Lewis structure standing for SO3 2- SO3 2- in this manner. Okay, hope you have enjoyed drawing of Lewis structures with us. Then students, you could easily try this out standing for other molecules and ions with 1 mid atom. Then what about if you have more than 1 mid atom? It's quite beyond our scope. Then students, in that aspect, you need to have an idea to be provided with at the very beginning. If you have more than one central atom, they need to guide you, giving the skeleton at the very beginning. Otherwise, we can't decide what kind of structure it would be carrying. Okay students, when it is uncertain the mid-atom, when it is possible you to find out more than one mid-atom, you need to be guided, providing you the possible skeleton. If they are providing you the skeleton only, you could draw that. Otherwise, you could go through misled structures. So it's 1, 2, 3, it's possible it to be either this, you are going to find this out in your organic chemistry. So it's 1, 2, 3, it's possible to be this as well. It's further, you could draw many other structures, what we are going to name them as with the name as isomers. Then students, that's what. Therefore, you need to be guided with the proper skeleton. Okay, it's with such, we are going to wound it up here in this lesson, showing you how to draw Lewis structures. Students, hope you have enjoyed and you have understood how to draw those Lewis structures. Finally, you have got the hope that you have got the competency of drawing Lewis structures. You try out drawing Lewis structures for finding for any molecular ion that you find there out. You could repeat watching this video, watching channel NIE YouTube channel, and it's asking you to be with us. We are going to wound up here. Students, goodbye.